Robert Tokinoa. Welcome everybody to this August webinar of the AI Researchers Association on large language models, what, how, implications, and potential. We are recording this webinar, so just let you know. Yeah, my name is Albert Buffet. I'm co-chair of the AI Researchers Association and director of the AI Institute at University of Waikato. So yeah, as you know, large language models, and in particular ChatGPT, is becoming very, very popular and very important right now. So we are very excited to have this webinar with these two talks by two experts like Johan Barthelemy and Paul Gersema. And so the idea is that we'll do this, we'll have these two talks, and we have a little bit of Q&A and some closing comments at the end. So yeah, just let me start. Let me present the first speaker, Johan Barthelemy. So he's currently a developer relation manager at the Asia Pacific South Division of NVIDIA. So Johan did his PhD in applied mathematics at the University of Namur in Belgium. And after that, he moved to Australia, to the University of Wollongong, where he joined the Smart Infrastructure Facility. And there he was the head of the Digital Living Lab. He focused on development of applications of AI on smart cities and environmental monitoring. And Johan is very well known for his expertise and passion for applying AI, and especially on how to accelerate it with GPUs. And now he's the developer relation manager at NVIDIA, where he's helping developers and scientists to build the next generation of AI-based tools with a particular focus on generative AI. So thanks, Johan, for being here. And yeah, the floor is yours.
Thanks a lot, Albert, for the kind words and the introductions. Hi, everyone. I'm very happy to be here to share a little bit about large language models and how to get started. So let me share my screen. Yep. Okay. So I hope everyone can see my screen now. So it's going to be a very, very brief introduction about what are large language models and how you can get started quite easily with them. So let's start with what are they and why we need those, or why they are quite useful and relevant nowadays. First of all, I'd like to mention that, well, thanks to Stable Diffusion and ChatGPT, now AI is kind of mainstream. Everyone heard of it, and a lot of us, if not everyone, already played a little bit with it. Right, so we all use ChatGPT to have a conversation with a chatbot and ask questions and get answers. We probably played a lot with AI avatars, whether it's in video games or maybe when you have a conversation with a smart assistant for your bank. We can use AI to create news stories. So it has been used to create books for children a few months ago. And it's all basically encompassing into the generative AI trend, where we take an input, a prompt, and then the AI, the model, will generate something else, whether it's an image, whether it's a text, a 3D model, a video, a translation, you name it. But what's really interesting is the speed at which generative AI and large language models have been adopted by the public. It took less than 2 months for ChatGPT and OpenAI to reach more than 100 million of users. To put that into perspective, Facebook took 42 months to get to the same level. So it's very, very fast when it comes to adoption. Another statistic that I like is the speed it took from research to actual production and actual use cases. It was only done in 5 years since we invented transformers when that was found by Google and University in Canada. So it really took 5 years from research to production, which for research is quite unheard of, right? So it's very, very fast moving. It's speed of light. And why? Well, simply because LLMs, so large language models, and generative AI, they unlock a lot of opportunities. Of course, as you can see on the left side, we can play with chatbots, right? You can ask questions. So for instance, how has NVIDIA contributed to the acceleration of AI? Then you'll get your answer from the chatbot. Now, basically mentioning that thanks to GPUs, we accelerated the models and now everyone can play with it. But that's not the only application of LLMs. There is, of course, other type of text generation tools like summarization, or you can think of translation, so transforming a sentence in English into French or any other local languages. You can use it to help you coding something. So you can ask a model to give you the Python code for a game, for instance, or to do some data analysis for you. You have all the tools around image and art generation, right? So I'm sure you are familiar with DALL-E or Midjourney or Stable Diffusion. And last but not least, it has a huge impact in life science. So you can use large language models to basically find new molecules, new drugs, new vaccines, or you can use it to analyze a lot of medical data as well. But what are large language models? Well, it's simply a neural network that has a lot of parameters. And when I say a lot, I mean billion or even trillion of parameters. Because they have so many parameters, they need to be trained on huge datasets. And when I say huge, I mean internet scale datasets. ChatGPT has been trained on basically the whole public internet data. Because they are so huge and they've been trained on such a big data set, they can be used to so many different tasks. They are highly generalizable, right? So you can use it to translate, predict, generate text, or create even new content. And behind the scene, they are powered by transformers. So not really the little robots that you can see at the bottom right, but clever algorithms. And I'll give you an overview of that a bit later. Now, why do we want to use large language models? Because actually, natural language processing has been out there for quite a while already, right? So traditional natural language processing approach are smaller models that are able to perform a lot of different tasks, but each model can be used for one particular task. So you need one model for translation, one model for sentiment analysis, one model for Q&A, one model for summarization. So it's quite easy to build, right? There's not that many parameters, but they're highly specific, and it means that you need to retrain those models quite frequently. So it's a lot of work, right? And it requires labeled data. So for each record that you want to use in your training data set, you need a proper, accurate label. Well, if you have a ton of data, you don't want to actually label it, right? You want to be able to use unstructured data. To do that, well, you will need to use models with billions or trillions of parameters so that they're able to pick up patterns and correlation inside that training data by itself. And at the end of the day, it means the model is highly general. So a single model can do many, many tasks. And that means that you don't need to retrain them that often. Right? What we found out actually with LLMs is there can be zero-shot or few-shot learning. So even though you train them for one task in mind, they can actually perform other things out of the box. And that's because they've been trained on a very large corpus of data. In addition, we can get them to learn new tasks, right? So, and it's just about being able to ask the right question, the right prompt to the model. So you have a single model that can serve all use cases. So when you want zero shot, you've got a lot of data that cannot be labeled easily. Then that's when large language models make sense. As mentioned, they are built on the transformer architecture, which is a deep learning model that is all about attention and self-attention. So the main idea behind transformer is the ability to pick up correlations inside the input sequence, the output sequence, and between the input and output. Those models are very, very good when it comes to generalization. They are built on top of the encoder-decoder architecture. So based on an input, the encoder will convert that into an embedding space, a numerical representation, internal representation, you might say, and then the decoder will take that representation to create an output sequence. So the input can be a sentence in French, The encoder will translate that into its internal representation, and then the decoder will take that and convert it into English, for instance. What's interesting about transformers is actually you don't need to use both the encoder and the decoder at the same time. You can have models that are only relying on the encoder. So that's where you've got models for understanding sentences. So classification, entity recognition, or extractive Q&As. That's models like BERT, Albert, and Distilbert. You can have models only relying on decoders, and those are very good for text generation. And that's what GPT is basically using behind the scene. GPT stands for Generative Pre-trained Transformers. And then on the right side, you've got the complete architecture for the transformers, the encoder decoders. And they are very good to generate new sentences depending on a given input. So they're good at transforming an input into another output. And that's why you'll see things like translation and summarization. The models here will be T5 or MT5. Now, if you look at the most popular model, ChatGPT, right? And ChatGPT is also built on top of a large language model, as I said, a GPT architecture. That one became very popular because it was very easy to use and allows natural conversation with a user. And out of the box, you have many different types of capabilities for ChatGPT. So you can ask it to explain a given concept, ask it to help you code something, even ask to help you analyze data. But you might want to know why would I be using large language models? Well, the main use case would be text generation. And why do you want text generation? Well, you can ask ChatGPT to get a proper answer, right? So if you ask it, why should I use large language models and how is it going to disrupt? It will give you a couple of hints that are quite relevant, I believe. So first, it tells you that you can use large language models to enhance tools and services by adding a bit of AI. So if you need help using a tool, you can ask a large language model and it can understand the question and give you a solution using natural language. It can be used for education. So you can quickly draft personalized learning experiences with those kind of models. And it has a huge impact in healthcare and diagnostic, as I mentioned before. But my favorite use is to use text generation to help me code very efficiently or much quicker. For instance, you can use Google Copilot to suggest codes while you are typing. So Copilot will actually analyze the code you already put into the editor, and it will guess what you want to achieve and provide some suggestions. That AI has been trained on basically the whole code on GitHub. So billions and billions of lines of code, and it's multilingual. So it can do Python, JavaScript, HTML, you name it. Every language on GitHub, Copilot can play with it. You can also integrate LLMs into your own workflow, right? So it's very easy to build APIs and plugins and extensions to your favorite tools so that you can take advantage of AI. So here you can see how we integrated ChatGPT with Unity to quickly build scenes, change the lighting, etc. So that's all about shadow programming in this case. Now, if you wanted to build your own text generation tools, that's quite easy, actually. The entry level is not that hard. There are some low-code pipelines that exist. Typically, you can find those on Hugging Face with their transformer library, and they've got a lot of good tutorials. If you wanted to use something based on a web-based API, you can use Nemo services, which is our online access or online API to models. If you want to train models, there are a few frameworks out there. For NVIDIA, we've got Nemo and Nemo Framework that can help you build an end-to-end pipeline for LLMs. If you have a model and you want to optimize the inference, you can use Parser Transformer and TensorRT. And if you want to deploy that model, we've got Triton Inference Server. I will give a bit more details later on. So I would like now to show you what kind of solutions we have at NVIDIA that you can use actually today. So if we look at generative AI, we've got a few solutions that are available. We've got 3 different services. So Nemo service for large language models, BioNemo service for large language models dedicated to healthcare, and Picasso service dedicated to content creation, more like artistic creation. But all of them are actually built on top of our Nemo framework. So Nemo framework is the SDK or the framework that you can use to build any type of generative AI model, whether it's an LLM or something like stable diffusions. Nemo framework can run on premises, so on your own workstation, on your own data center, or on the cloud. Everything that I showed you here can be actually cloud native or deployed on your machine. So let's deep dive into Nemo framework. As I said, it's an end-to-end workflow to help you build, customize, and deploy any type of generative AI model, whether it's speech, language, or image creation. So the framework is kind of simple. We provide 2 ways to build models. First of all, you can start from scratch. So we provide tools to help you download big data sets from internet and pre-process them so that you can then efficiently train them on GPUs. So that's the foundation model building path. If you don't want to start from scratch, we also provide a set of pre-trained foundation models based on the GPT architecture. We also allow you to import some community models. So whether you go with the pre-trained models or you build your own, once you get that foundation model, it's time for customization. And that's where we allow you to do some customization using reinforcement learning or using p-tuning or supervised fine-tuning or using LoRa, for instance. So there are many different methods that you can apply to customize the model for your own research or your own enterprise use case. Once the model has been trained, it's time for inference, and we also provide tools to help you accelerate the inference of the model so that you've got the maximum number of words or tokens per second with a minimum latency. We also provide guardrail, which is a tool that allows you to keep the model stay on topic, right? So it helps you to remove bias and toxicity when it comes to interacting with the LLM. And everything takes advantage of GPUs. So you can accelerate everything as fast as possible. Now, why did we build a lot of those tools? Well, when it comes to build foundation models, you find that there are a few challenges. First of all, there's a lot of data to deal. It's terabytes or even petabytes of data. You need a large-scale compute infrastructure, which costs a lot, and it's also costly when you want to use it. You need a lot of expertise as well when it comes to use algorithms to train models on multiple GPUs. And using those large-scale infrastructure also requires their own kind of specific methods and models. So that's just to build a foundation model. When it comes to customize it, well, you know that some of them actually don't come with the right knowledge. If you use a model from ChatGPT, it's very likely they don't know anything about your mining company, for instance. Also, those foundation models are typically frozen in time. They've been trained on data from 2021. They don't know anything that happens after that, meaning that when you ask them about something they don't know, they will hallucinate and provide bias on incorrect information. So let's see how we can cope with those changes. First one, for the data, we have the data curator tool. So we allow you to, we enable you to download internet scales dataset and actually extract what you need from that dataset. Maybe you just care about English, or maybe you just care about another language. We can do that kind of filtering for you. Then we can also apply some classifier based on some rules that you might define or the topics you're interested in. Maybe it's energy, maybe it's science, maybe it's legal. We have then the deduplication tool that makes sure that you don't have twice the same document or the same information in the dataset. If you're using multiple datasets, then we have a data blending tool that helps you optimize how you should combine those 2 datasets. And then it's ready for training. The end-to-end process for a 60 terabyte data set takes only 3 days if you are using a node with 30 CPUs. Now, data blending is very, very important. It's actually better to be able to use your own proprietary data during the pre-training stage rather than do fine-tuning. That's one of the key learning we found when we were working with Bloomberg to develop the Bloomberg GPT model. So Bloomberg used a lot of public data set, but they also added their own internal proprietary data, and that only represents 0.7% of the total of the data set. Even by just doing that, that helped them beat the state-of-the-art model by more than 10% on average. So even if you've got a little bit of data, you should consider using that at pre-training instead of fine-tuning. The sooner you can incorporate the data into your pipeline, the better it is. Other issues that might be other challenge that can come when dealing with LLMs is how to pick the right hyperparameters values for training. If you are familiar with machine learning and deep learning, you know that there are a lot of parameters you can play with to optimize the training. So what's the number of epochs? What's the batch size? Which optimizer I should use? What's the learning rate? What's the strategy for changing the learning rate? Well, we provide a configurator tool to pick for you the right values for all those hyperparameters. And also, if you provide the budget you have in terms of time to train a model, it will tell you what type of architecture is the best. Is it a GPT with 10 billion parameters or 40 billion parameters or 500 billion parameters? Well, the configurator tool will help you pick that value for you. We provide also a lot of different techniques to speed up the training, right? It's all about being able to split the data and the model onto a different set of GPUs in parallel, and applying also different types of techniques like activation recomputation to save on the memory footprint, meaning that you could train larger models. But it's all transparent for the user, just a parameter to change in a file to select all those algorithms. Now, using those kind of tools, you can see here how long it will take to train a model with different numbers of parameters, considering that you have a data set with 300 billion tokens in your training set. Right. So if you had 64 GPUs and you wanted to train a model with 5 billion parameters, it will take roughly 10 days. Now, if you had access to 800 GPUs, you could train a model with 175 billion parameters in less than a month. GPT-3, 175 billion parameters, that's the same size and the same architecture as ChatGPT. So if you wanted to build your own ChatGPT, there you go. You would need a month using 800 GPUs. So that's just to pre-train the model. But once you've got your model that is pre-trained, you will want to customize it to address some specific tasks. For instance, if you use the pre-trained model out of the box and you ask it a question, what is the yellow part in an egg? Well, the model will answer you something like, this is the part that is suspended in the center of the egg. The answer is correct, but it's probably not the only one, right? Depending on the context of your application, you might want to have a different type of answer. So the idea here is actually to add to the prompt, the question from the user, a context, a trained prompt. So that context can be seen as an auxiliary model to enrich the prompt and will drive the LLM into the right direction. So if the context was nutrition, then the LLM will actually answer that kind of output at the top there. So the yellow part in an egg is the yolk. It contains fat, cholesterol, and protein. So it's all about adding or enriching the prompt with a context in this case. And that's what we called a p-tune response, because this context there, it's a small model that you need to train so that whenever you ask a question, it is automatically enriched with the right information, the correct information. Doing that kind of p-tuning, it's very, very simple. Basically, you need a few hundred examples of input and desired output, like any type of machine learning or of deep learning. And you will train a small model, and typically an LSTM model, that will generate the context and attach it to the original prompt to create a new input embeddings that will go into the LLM. You should note that in this case, the LLM is frozen, meaning that when we train the LSTM to add the context, we do not touch it. So it's very, very cheap to do p-tuning. Right? It requires less time and less infrastructure, less memory. So basically, that model is 100,000 or maybe less than 1 million parameters. So it's several orders of magnitude lower than the original LLM. P-tuning is not the only way to actually customize the model. We can use reinforcement learning as well. So that's something that is also achieved by ChatGPT. So each time you've got a prompt, the model will generate an answer, and then you can rate that answer with thumbs up or thumbs down. And that feedback can be used to inform the LLM about its performance and use that as a feedback loop to improve the model. So the next time we can actually encompass that feedback information to make sure that the model will provide better, more accurate answers over time. So that's a very simple thing. I should note that it is available today. That slide is a bit old. Reinforcement learning, p-tuning are very efficient and very powerful tools. They are not the only ones. For instance, an LLM is trained and it's only aware of what was in the training data set, right? But the world we live in is very dynamic. So if you ask something about what happens yesterday, well, probably the LLM said, I'm sorry, I don't know. I was trained with data that is 2 months old, so I don't have the current data. So what we can do is actually use information retrieval techniques. So what that means is we want to connect an LLM with a data set. So each time we are going to ask a question or send a prompt to the LLM, we are going to create an embedding for the output of the LLM and compare that embedding with whatever is available in the data set to find the closest one, right? So it means that the LLM will be able to answer with the current or the latest information available. So you can see it as a knowledge repository for the LLM to enrich the LLM's answer. I mentioned guardrails, which is an open source tool that you can pair with any type of large language model framework, whether it's NVIDIA or not. And the goal of guardrails is actually to keep the model on topic, right? If you are building an application that is about sport, you don't want it to answer questions about chemistry or politics, for instance. It also tries to make the model as safe as possible. So we can monitor the input of the user, making sure it doesn't try to cheat the system. And also we make sure that whatever is being outputted by the LLM is also something that is safe. So that way we can also prevent hallucination, toxic or misinformation. Guardrails also allows you to implement some security methods. That way you make sure that the model does not leak private information as well. So by using all the techniques I mentioned before, basically you've got a complete end-to-end pipeline to create your own foundation model, right? So you start with a pre-trained model, whether it's something that you have fine-tuned or created from scratch. Then you can apply a set of customization to include new knowledge, to include skills, and to remove everything that is not relevant. And then you can finally connect your enterprise model with your own proprietary data set using information retrieval. And that's how you can build your own use cases, right? So that way, again, to summarize, you've got something that can answer proprietary information, meaning that it's factually correct. You can update the knowledge base in real time. So the model will always have access to the latest information. And you can manage bias and toxicity very easily. Now, I focused a lot on language model, but you should know that the same framework, NeMo, is able to train models for image, right? So we've got stable diffusion, pix-to-pix, dream booth, vision transformers, and also clip. So that's a multimodal framework. So it means that, yeah, in addition to your beautiful language models using GPT, T5, MT5, BERT, or BloomZ, or Llama, you can have text-to-image and image-to-image models. Now, we understand that NeMo framework is quite advanced, so you need some coding skills. So we also have the NeMo service, which is basically a web user interface to help you fine-tune some of our foundation model. So we provide access to a few of our GPT models, as well as informs, so information retrieval techniques, to customize your own model and also to perform inference via APIs. So that's a low-code solution to give you access to state-of-the-art models. Speaking of inference, it can be quite complex, especially when it comes to deep learning, machine learning, and large language models. You have a wide variety of frameworks that are available to build your models, like PyTorch, TensorFlow, ONNX, OpenVINO, TensorRT, scikit-learn. So what we built is the Triton inference server, which is able to actually serve model built with any type of platform that's able to run the inference on CPU and GPUs, making sure that you have the best usage of your hardware, and you can configure it to serve any type of queries, whether it's offline, batch, stream, or even real-time queries. And you can use it to maximize the hardware that you have. So that's the goal of Triton. If you want to get the best of your model, you might want to use TensorRT, which is there to help you optimize your model. So TensorRT can be seen as a kind of compiler for AI models. Whatever framework you use to build your models, you can run it through TensorRT to generate an inference engine that will be targeting the specific hardware you have in mind for deployment, whether it's a Jetson at the edge, or a data center GPU, or a workstation GPUs, or even the drive platform if you are building an autonomous car. But just to give you an idea why it's good to use Triton and TensorRT, you can have a look at the two graphs on the right-hand side. So that gives you an idea of the speed up you can achieve compared to CPU when using TensorRT and Triton. So the gray bar would be when you run a GPT-J 6 billion parameters model on a single CPU. If you use it with PyTorch, you get a speed up of roughly 8x using a GPU. Now, if you apply TensorRT and some of our faster transformer optimization, you can get a speed up to 22x on the same hardware. Now, thanks to faster transformer and Triton, you can actually split the model on multiple GPUs and get a speed up to 32x. That's the same story for T5. Actually, here, it's the difference between being able to run a model in real time and having to wait for a few seconds before you get the answer from the model. Right, so very, very fast. Just to wrap up, I'd like to give you a quick demonstration of what you can achieve with NeMo when you pair that with other tools to build your own avatar. So what I'm going to show you is an unscripted conversation with an NPC that is powered by an LLM running on NVIDIA NeMo.
We are thrilled to showcase an immersive and dynamic interaction between a player Kai and a non-playable character named Jin. This captivating ramen shop scene was created by NVIDIA using the latest RTX rendering technologies. NVIDIA collaborated with Convey, an NVIDIA Inception partner, to showcase how developers will soon be able to use NVIDIA Riva, NeMo, and Audio to Face for AI-powered speech, conversation, and animation. These models were integrated into the Convey Services platform and fed into Unreal Engine 5 and MetaHuman to bring Jin to life. Please take a look.
Hey Jen, how are you?
Unfortunately, not so good.
How come?
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful, Kai.
So all the conversation here was done in real time, which I think is kind of amazing. So yeah, to quickly wrap up, just in summary, you can see LLM and generative AI as a way to help you boost your productivity and also creativity. LLMs can be used to help you co-author a paper or to co-create codes for a research project or to help you design marketing material. So all the idea here is to help people to boost productivity and creativity. Now, using and building LLMs, there are a lot of challenges all over the journey, and we provide tools to help you solve those. So we've got the data curation tool to help with pre-processing and collecting data. We've got tools to help you with multilingual support for language models. We know that finding the right combination of hyperparameters is difficult, so we've got the hyperparameter tool. We also provide recipes that are that are tested and validated for GPT and T5 models. So if you follow the recipe, you are certain that your model will converge in the given amount of time you have. We provide scripts and documentation to run on different platforms. And of course, for inference and deployment, we have all the quantization techniques to make the model as fast as possible while retaining the accuracy. So it's an end-to-end pipeline from collecting data to training to deployment. You get the fastest possible performances, and it's quite easy to use because it's basically 2 containers that you can download for free. So 1 container for training and 1 for the inference. Can run anywhere. A lot of it is open source. So you can actually dig into the code. If something is missing, you can implement it. And the recipe are tested a lot by our team to make sure that if you use one, you'll get convergence of the model. I'll share the slide with you, but if you're interested, there are a lot of getting started material there. The only thing you need to do to use it is to join the developer program. It's a free program that will give you access to more than 450 software development kits that we have that include also pre-trained model. So yeah, join us, a lot of freebies. And if you're thinking about doing a startup, we've got also a program that can help you with technical expertise and also support from a hardware point of view. And yeah, thanks a lot for your time. Now I think it's time for the following speaker. Thanks.
Thanks, Johan, for this very nice and inspiring and useful keynote. So let's go to the second speaker. We have the pleasure of introducing Paul Jetsema. So he works at University of Auckland, and he's the author of the book Machine Learning for Managers, published this year. He has been serving as the treasurer of the AI Researchers Association and continues now on its board. He did the preparation of the discussion paper of the association, ChatGPT and large language models. What are the implications for policymakers? So Paul is very well known for applying machine learning methods to solving problems in finance and business. He has published in numerous international peer-reviewed journals like the Journal of Accounting Research and the Journal of Banking and Finance. And prior to returning to academia, Paul worked at Barclays Capital as derivative trader in Hong Kong and as sell-right research analyst in London. And yeah, let me end just mentioning that he just published this recent book, Machine Learning for Managers, that is presents a very nice and useful introduction to machine learning from a management perspective. So thanks for accepting the invitation to talk today, and yeah, the stage is yours.
Thank you, Albert. Well, good afternoon, everybody. So firstly, thanks, Johan, for that very detailed overview. This was always more to learn, and this space is moving so fast. It's really helpful to see the various things that can be done. So I guess we're going to be covering the same topic, but from a different angle. And my background is I'm more of a tool user than a tool maker. But what I want to stress is that large language models and generative AI more broadly is a really important technology. And I think it's not an exaggeration to class it as one of these technological revolutions that we get from time to time, such as the internet, cloud computing, even electricity. So let me briefly recap all the things that Johan already told us. What we have here is large language models. Perhaps the best known one is ChatGPT. So what do you need to know? So at its core, it is a model that predicts the next token, and you can think of that as the next word. So if you give it some text, and a text is basically a sequence of words, right? At the risk of oversimplifying, all that it does is predicts what is likely to be a plausible next word. And of course, this is not a new thing. We could do similar things, 10 years ago. What is different is that it now is able to do so in a way that exhibits new kinds of abilities. So the underlying technology, as Johan said earlier, is a transformer. It's based on attention is all you need. That is probably up to about 100,000 citations to date. So it's obviously gotten a huge amount of exposure. And why should we care? So what is the hype about? So I guess if we take a historical perspective, prior to these large language models, we of course had AI. We even had AI that could do useful things. But every time you wanted to solve a problem, you had to specifically train a model to solve exactly that problem. And not only that, you had to give the model examples of how the problem is solved in the form of labeled data. That is to say, here's the predictors and here's the answer I want you to get. Go train yourself on this, and then if you're lucky and if you have some skill, you get back a model that is able to take predictors and predict something with it. What is very, very different from large language models is that at some point when they got big enough, they started being able to solve problems that they were not specifically trained for. So recall that I mentioned earlier that all that these LLMs essentially do is predict the next word, right? And by iterating through that, you predict the next word and the next word, and so after a while you produce some text. And so it's not difficult to train a model, any model of this type on, say, Shakespeare and get text that sounds like Shakespeare. But what happens when the model becomes big enough and it's got enough parameters is it can do all kinds of things. So here's a list of them. It can follow detailed instructions. It can remember the context of what was discussed earlier, if it's in the form of a chatbot. Generate original written content in any domain. It can do math, right? It can translate between different languages. And at no point, we should stress, was it ever specifically given input and output saying, this is English, this is French, now go and learn it. It basically learned it as part of, going through this mass of data scraped from the internet. It can generate computer code and all kinds of things. So why is this a big deal? The emergence of these other abilities points to a general type of intelligence. And, although the philosophers will argue about it, in my mind, this is an intelligence. It's, of course, not a human intelligence. It is a kind of alien intelligence, but, it's certainly more intelligent than a dog. And if you've ever owned a dog, you wouldn't, argue that a dog is not intelligent. And if you've used a tool like ChatGPT for a while, I think it's hard to say that it's any less intelligent than a dog. And therefore, by a process of induction, we're dealing with an actual intelligence here. And so the question is, what can we do with that? So firstly, why is this such a big deal? This is a very important graph, and it is in the publication of the GPT-4 technical paper. The blue bars is the GPT 3.5, kind of the old GPT, or the free GPT, if you like. And the green bit is GPT-4, which comes in two flavors, with and without vision. But what is it measuring? It is measuring its ability on standardized exams as a percentage of other test takers. So this is not in comparison to the population of people as a whole. This is in comparison with actual test takers, who presumably are people that feel they know enough to actually take the test. They've studied this, they're ready to sit the test, they want to pass it. And what you can see is that across a whole range of different disciplines, ChatGPT scores at human level or beyond. So that demonstrates some of the abilities. But what does this mean for people in business, for people in society, for students, if you're an employee? The first thing here is that I think it's a good idea to become friends with the AI. You really want to have the AI on your side. Firstly, you should be aware that you may have to compete directly with AIs, and there are already jobs that are essentially decimated by this. We'll give a few examples later on. And more jobs will feel the impact of AI. So what is going to happen is that to be relevant, you will need to compete with other people, but you also have to compete with people that are using the AI. And in many domains, you won't really be competitive if you don't do the same. So it's a matter, I think, of self-interest. What can you do from a practical perspective? If you haven't already played around with this stuff, that now becomes a very small number of people, but in any case, certainly you should. And don't just spend 15 minutes. Lots of people try it for 15 minutes, find that it's not quite what they expected. But people that have used it a few days or a week, they suddenly figure out what works, what doesn't, and how to use it. And I'm one of those people. I've been using it for almost a year now, and I can't imagine a world in which I don't have access to this tool. I should stress, of course, that these LLMs have both strengths and weaknesses. So the one thing to be aware of is that they are superb liars. So when you ask them for something, they'll look for the facts that they need, and if they can't find them, every now and again they'll just invent something. And I'll have to say that the tools have gotten better. They do this less and less, but it can still happen. And so to really be able to use these tools well, it helps if you have some expertise in the same domain, if only for being able to detect when it is kind of leading you in the wrong direction. Having said that, if you're not an expert in a field, this kind of technology is also very useful for quickly getting you up to speed. It's in a way, it's like having a tutor that's available via chat or email that will respond immediately 24/7 and never get annoyed with you. So here's an example. We've seen this before, but I think that gives you a sense of just how far you can take these tools. So this bit of narrative here is essentially asking ChatGPT to write some code in Python. It is to predict CEO turnovers, which basically means, can we predict whether a CEO of a company is going to either leave the job or be fired? And we want to use a 3-layer neural network, which is pretty vanilla. And so all you have to do is basically know enough about AI to just state what you want. And you hit enter, and out comes the code, beautifully written. I've run this code, it works. And what is truly impressive about it is that this is not just kind of blindly following your instruction. It has enough understanding of these things to fill in the gaps. So for instance, it uses binary cross entropy. Now that's a very technical thing, but basically if you are predicting a 0-1 variable, either true or false, or did it happen or did it not happen, such as did a CEO turnover event happen, yes or no, then you should use binary cross entropy. Otherwise, if you're just predicting a number, then you typically use something like mean squared errors, and it knows enough about the background to automatically do that for you, even though you didn't specify it. So I think that shows the power of this. It goes without saying that you should actually look at the code and not just trust it, which is where it comes back to the idea that in order to really use these tools, you do need a minimum level of ability in the domain yourself. As Johan pointed out, this is not just about generating text or even code. You can generate pictures, video is coming, and more to the point, we are going to go to a world that is multimodal, i.e. seamlessly being able to move between text, video, sound, audio, images. So, to give you an example of what you can do, I recently had to present on financial data science, which is something that I know a little bit about. And I thought, how can I kind of motivate people, get them kind of in the right frame of mind? Now, you could start with like an opening screen, but for that you need an actual artist, right? Or at least you used to be able, you used to need an actual artist. And I'm not an artist, and I don't have the money to employ an artist. But with generative tools, I don't need that, because I can simply type into something like Stable Diffusion or Midjourney what I want and get something like this. Data science for finance. And I think what's particularly useful here is to read that prompt at the bottom. So it says here, short of a medieval data science from behind, the data scientist is coding on several large futuristic screens inside a Gothic library with diffuse lighting. And I think, all things considered, this is not bad. Now, the truth is, this is not the first one. I had to play around a little bit, but within 15 minutes, I had something that I liked. And there you go. And, if this is your actual job, producing these kinds of imagery, perhaps, in the more creative side of the workplace, a tool like this, I think, is indispensable. So there we go. Sorry. Okay, so apologies for that. I just need to. Right. Okay, so what do we make of all of this? So the first point to stress is that this is now a vast ecosystem. It is not just ChatGPT. There are hundreds of models out there of various abilities. Some of them are very close to the GPT-4, which is kind of leading the pack at the moment. Others are kind of toy models and everything in between. Now, Johan kind of gave us an overview of what you can do. So this is kind of my own take on it. Firstly, if you want to create your own LLM, at this point, it is still not something that everybody can do, right? So if you want to train a powerful LLM from scratch, you'll need this kind of money. And I was happy to see that Johan's numbers kind of matched up with mine. And a reasonably competent AI research group of your own. Who can do that? Well, Bloomberg, for instance, created Bloomberg GPT. So, if you're a large corporate, you have this kind of money and you have the ability to attract the right kind of talent or partner with the right kind of people to get that kind of technical skill set, then you can do that. Of course, the second thing you can do is you can fine-tune an existing model. Now, there's a couple of ways of doing this. You can take an existing model with its weights and then add data and retrain it. As Johan pointed out, sometimes it might be better if you just rebuild the model from scratch, but of course that will be more expensive. There are new technologies like low-rank adaptation, which essentially allows you to train sort of like just part of the model. So you don't retrain all of the parameters. There are certain parameters that you retrain and others that you leave alone. And what that allows you to do essentially is take an existing model and just layer on top your own low-rank adaptations that reflects the kind of skills that you want the model to have. Or, and I think this is what most people will do, is you can go the API route. So that is to say, you access an existing commercial model that's hosted on the cloud via an API. Now, the good thing about that is the code for that is pretty straightforward. It's like 12 lines of Python code, and you're off to the races, right? Of course, you won't get a custom model, but it's still very powerful, particularly if you use prompt engineering. It is going to cost you money because every time you make a request via the API, you'll be charged. And privacy, of course, is a consideration, right? So at this point, I think it's fair to say that lots of corporates are hesitant because a lot of the information they might want to have in a model is also very proprietary. But my understanding is that these days, even models such as a GPT-4 can be accessed via dedicated cloud hosts where you have some guarantees about privacy, but obviously something that you need to look into. So let's talk about some examples. So I think the one that kind of like was right there at the beginning is marketing. So a bunch of people used to make a living from so-called copywriting, which is, you know, the type of writing you get on ads, newspaper advertisements, the stuff that's on websites, the promotional material that's printed on flyers, and so on. And it turns out that large language models have seen a lot of this in their training data, and they're rather good at it. And so I think at this point, you don't want to be a marketing copywriter because, frankly, there's very few jobs left there. If you are going to go in that direction, you probably want to be somebody that is good at organizing the workflow around copywriting, and you'll just have an army of LLMs that will do the actual copywriting for you. But, you know, it's not just that. In education, Khan Academy has trained an LLM called Khanmigo. I think that's a play on words on amigo, which is friend in Spanish. And essentially, this is a chatbot that's trained to help you through some of the educational material that they provide. Search engines like Microsoft Bing, they already use this technology. Johan gave that example of GitHub Copilot. And, you know, by the way, that if you do any kind of coding, this is a godsend because no matter what your area of expertise, it has limits, right? And you may want to do something that's a little bit outside of what you normally do. And the traditional way is you would, you know, try Google and you'd go through a bunch of Stack Overflow websites and you know, try and piece together some code that works. And eventually you'll get there, you know, and then you close down the 72 tabs that you opened in the process. It's much easier now. You basically say what you want. It gets created by the LLM. Then, of course, you need to check that it does what you want, make sure that you understand it, but it's a lot more efficient. Copy editing. So the idea of paying somebody to proofread something, I think that is a dying occupation. Because frankly, you can just give the same material to ChatGPT and ask it to pretend to be a copy editor or you know, to proofread it for you. Idea generation is another one. And unlike many other revolutions in IT, this is affecting the kind of creative side of business, right? So if you're in the business of making movies and you're working on a script, you might get to a point where you're kind of stuck and you can just literally ask an LLM, well, you know, where can I go from here? Give me 5 possible, you know, plot evolutions, and it will do that. Legal documentation. Now, in a previous life, I spent a lot of time going through legal documentation that underpins contracts in the hundreds of millions of dollars, right? So when that's on the line, you really have to read every single line very carefully, make sure that you don't miss anything. These LLMs have an uncanny ability to read a lot of text and remember it and connect the dots, so to speak. And so while it's still not a substitute for a good legal background, what it can do is it can go through a mass of documentation and pull out the things that are relevant to you. So I know that there are people in insurance that are already working on applying it in this context, essentially asking, you know, here's a claim, here's the insurance contract, you know, is the claim covered or not, and why? And this one is nice because it really applies to pretty much any non-trivial company. if you're a company with, say, more than 500 workers and 20, 30 million plus in sales, then you, I think, really would like to have an enterprise knowledge base that is LLM enabled. And so if you, of course, taking into account privacy considerations, but feed it all your emails, all your internal documents, everything on your internet, your customer production records, basically let it see everything in the firm, then you'll end up with someone or something that basically acts like a old-time employee that knows how the whole firm works end to end. And that can be really, really valuable, as anybody that's joined a new firm knows. The first few months, you're just asking, well, how do I get this done? Who do I talk to about this? What is the process for doing that? And, most of those things are embedded somewhere in the organization, but it's not easily accessible. I think LLMs have an ability to surface that, and that will be very, very valuable. So how do we get results from generative AI? I think the first point to make here is that you can't just sprinkle AI on top of an existing business. This is not a fairy dust. If you want AI to help in your business, you will need to first understand what it can do, and then you need to re-architect the business to kind of make use of that and exploit its abilities, compensate for its weaknesses, and re-architect the whole business to exploit it fully. And so you can see, for instance, this happened when we had electricity, when computing came along, the internet, cloud computing. All of these revolutions, the companies and the organizations that benefited from this were not the ones that just used it superficially. They are the ones that understood how this new technology could allow them to do things in a fundamentally different way that is either more efficient or creates more value for their clients, and therefore create value. What I will say, though, is that it's going to be so much easier if you are a data-first company. And for this reason, I think it's not strange that some of the large tech firms or technology-oriented firms are the first to really benefit from generative AI and AI in general, because they already have a data-first philosophy. They see data as a core asset, and that they care to make sure that they have good quality data in ways that are easily accessible. I will add this one point. I don't think most organizations will benefit from trying to build all of these things in-house themselves, particularly if you're a smaller firm. It's not really feasible for you to build state-of-the-art models. What I will do instead is to look around at what is available from service providers, and believe me, this is an ecosystem that is growing day by day. And see what's out there that could be useful in your business. And if you adopt that early and if you integrate it into your business process well, you can already get a lot of benefit. So one way to kind of illustrate this thinking is to contrast two ways of architecting a firm. So a lot of the firms that we currently have around us essentially reflect an industrial era architecture where everything was done by hierarchies, right? So you had production, and production basically built things. You had sales, and sales took the things that you built and sold them. And you had accounting and finance, and they basically keep track of all the numbers and produce the accounting reports, and so on. And HR, payroll as it used to be called, or HR now, or people talent. They basically took care of making sure you hired the right people, fired people when you had to, and so on. The problem with these kind of hierarchical and siloed businesses is they don't share data very well. And so to build anything that really shares data, you end up with what I call these spaghetti processes, which is very, very inefficient and makes it extremely difficult to change anything. One way to kind of make things better is to move to what I would call a data-centric approach, where you try and put all of the data in a common enterprise repository. Now, that is unfortunately not as easy as it sounds, but even getting 90% of the way there can make a big difference. The magic happens that once you have all your data in one place, or at least accessible via a single interface, then it becomes a lot easier to build functionality on top of that pulls in data from different sources, because there is now the one source that you can query, even if that source itself, your enterprise data repository, pulls in the data from disparate systems. So I think something that is going to be true for a lot of firms that want to apply generative AI and AI in general is they'll find that a lot of the effort will actually go into going from an industrial era architecture to a data-centric architecture. And once you've made that move, the additional cost of standing up new AI functionality will be a lot less. Right, so let's imagine you are a firm and you are interested in implementing some AI tools, perhaps one of these large language models. A few things to think about. I think the first thing to emphasize is that AI doesn't make money. Business does, right? And so just running some AI projects or building a model is not intrinsically going to make you money. What you need to do first is find a problem that is worth solving, in the sense that it'll make your business run better and more profitably. And then see how can you use AI to do that. And that means asking some hard questions. What is this AI system going to do, and how is it going to help the business? Who is going to build this model, right? It's easy to talk, but at some point somebody has to build it. When are they going to do it, and how much is it going to cost? You want to ask questions like, what level of performance do you need from this model for it to actually help the business? So these are, things that are, I think, important. And I think a lot of money is wasted by people building projects where nobody is quite clear about what it is supposed to do and how it's really going to help the business. In terms of talent, well, obviously you need domain knowledge in terms of the problem you want to solve, and you need some AI expertise. But what I would say is perhaps, in-depth domain knowledge and a little bit of AI can be more valuable than you think. And the reason for that is a lot of the AI tool sets are actually quite mature. And there's a lot of support that you can access along the way. Various consultants will help you and so on. So probably most of the talent you want should focus on domain knowledge. And it's often not too hard to upskill these already fairly technical people into some degree of AI expertise, right? So a typical engineer knows quite a lot of math, and it doesn't take too much to get them to understand what AI is all about. Having said that, for any kind of serious project, you probably still want one or two real AI experts, because inevitably there's one or two little difficult points that require that expertise. The final point I want to stress is that the most expensive AI project is probably the one you didn't build, but your competitor did build, and it was a roaring success. So, in terms of saving money, obviously you shouldn't build AI projects that doesn't, actually add any value. But you should also ensure that if there is an AI project that you can build that will add value, that you don't hold back, but that you do that before your competitors do. So a couple of diagrams that I've shamelessly pulled from my own book, how to manage an AI project. So look, most companies and most people that have managed projects, they're not doing this for the first time. So a lot of those skills are transferable. But in terms of AI projects, obviously be clear about what you want to do. And then it's always a good idea to do a little pilot project to check that what you want to do is even feasible, right? Oftentimes there are things that you would like to do, but despite your best efforts, it isn't actually doable with the technology as it currently stands. And if that's the case, you probably want to find out sooner rather than later. And then, you should have like a fairly automated process. A lot of those you don't have to build yourself if you're relying on, third-party cloud providers or technology partners. They have already a lot of these developed, so you can just leverage that. You obviously have to develop it. Once you're happy with it, you deploy it. And then this is the important thing, is you still have to monitor how it's going, right? Because just because it worked in development does not mean it will work in deployment. You have to keep checking. And any issues that surfaces from that, of course, goes back into the process. Couple of points here, right in the middle. These are things such as governance, security, privacy. They are not optional. In any real organization, it's not just about, a bunch of Python code that you throw onto a server. You need to think through these things first, because if you get this wrong, it can end up being very expensive. Right, and then the other thing I'll point is, although this is a nice little cycle, the truth is when you actually do it, there's a lot of back and forth. So on the right-hand side, I have a little kind of team layout, how you could possibly structure it. But the truth is every project will be a little different. Okay, so I'm going to wrap it up at this point. The first thing I want to stress is this stuff is real, right? Generative AI is not a fad. It's not a flash in the pan. It is a real breakthrough in technology. And whilst not a whole lot will change in 3 to 6 months, I think in 5 to 6 years, you will see very substantial change. If you've lived through the internet revolution, this feels a lot like about 1995-ish. To identify AI opportunities means you need to be willing to experiment and you need to invest internally in AI capabilities. And you need to understand that not everything will work. Once you have those opportunities, however, I think most of the benefit will accrue to those organizations that are able to fundamentally re-architect what they do and how they do it to exploit the powers of these new technologies. Final point is you can't just say, hey, we're going to sprinkle some AI on this and it's all going to be good. Just like adding .com didn't work for .com companies, sprinkling AI on top of your firm will not make you an AI-enabled firm. You have to start by thinking carefully about your business and looking for problems that are worth solving. And that's it from me. Thank you very much.
Thanks, Paul. Very nice talk. So now we have time for Q&A. So yeah, any question from the audience? Anyone who would like to start? Okay, if not, let me start with one first question. There's a lot of discussion about open source models and, let's say, closed models, right? Like ChatGPT and Llama. And so, yeah, I was wondering what are your thoughts on that?
I'll go first then. I think you should use the right model for your needs. If you can use an open source model and that's accurate enough for what you want to do, by all means, go for it. It's fantastic for research. It's fantastic to get started. What we've seen from experience is, unfortunately, the closed source model or the one that you can access with license, they tend to be a bit more accurate. Why? Because the companies put so much time, effort, and they've got much more resources than the open source model, typically. It's not always the case, but generally speaking, closed source or the one that you need to pay a license, well, there's a price for a reason, unfortunately.
Just adding to that, I think it's true. Certainly at the current point, the proprietary models do seem to be more powerful. I think it goes back to classic software engineering principles, is that if you have an external dependency, access it via an interface. And what that means to me is if you are going to use external LLMs, either proprietary or open source, it's a good idea to create your own internal interface for that and hide the complexity behind it. That means that if the world changes and suddenly it's the open source models that are more powerful, you can just quietly switch it out at the back end and you're not breaking anything. And this, by the way, is not a new insight. Software engineers have understood this for 4 or 5 decades already. But I think it is worth stressing because, once this kind of technology is going to be embedded in production processes. And once, you let everybody do it in their own way, it's going to be a very difficult exercise to disentangle it if at some point you decide, no, it needs to be done in a different way. And so a little bit of architectural thinking and investment up front, I think could save you a lot of headache later on.
Very good points.
Great. Thank you. Any question from anybody else? Okay, meanwhile, I have this feeling that one of the main issues right now is the technology is really, really good, but one of the main issues is how to distinguish hallucinations because the models are very confident, right? They never say it seems that for many cases it works really, really good, but there is always these cases of hallucination that goes wrong. So what are your thoughts on that? This is something that could be solved easily in the future, or this is something that, could be achieved?
I think hallucination comes from the lack of training data, right? So the model will start hallucinating when basically doesn't know what to answer. It's out of the scope of what it has learned. And that's why we need, it's going to be hard to build one model that is able to answer everything and anything, right? So that's why we see a lot of people or a lot of companies and researchers building, customizing all those LLMs. That's why we've got LoRa, p-tuning, prompt tuning, information retrieval. So there are a lot of techniques to lower hallucination, and there is also guardrails as well. But interestingly, we've seen a lot of open source models being good at academic benchmarks, right? But that doesn't mean they're going to be very good in real world application when you start hallucinating. So that's one thing to pay attention to. Spotting hallucination is still quite hard, and it can be very costly when it happens in production for companies.
Just to add to it, I mean, hallucination isn't always bad. If you are a creative and you're looking for a plot line, you want hallucination. That's called fiction. Yeah. So hallucination is really just fiction. I think, firstly, what I have noticed just as a user of these tools is that things have gotten better. And in the past, when you asked, the tools, prove this, and it is in fact not true, it would still try and prove it and come up with something that looks quite plausible, but when you're looking at it carefully, it's wrong. But lately, when I've asked it to prove something that isn't possible, it would go through all the steps and it says, well, it seems that what you've asked to prove isn't true. In fact, the opposite seems to be true, and perhaps, blah, 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 blah. That suggests to me that a lot of this may be, something that you can fine-tune the model. So in some situations, hallucinations are really bad, like, think medicine, for instance. You really don't want it. You'd rather it just say, look, I don't know. And that seems to me something that you can deal with at least partially with fine-tuning. And in other settings, you do want the hallucinations. In fact, that is all that you want. So I think it's a manageable problem. And what I will say is if you use any kind of LLMs in anything that's critical, right, where people's lives are at stake, or serious money is at stake, or your reputation is at stake, then you need additional processes, some kind of human oversight. You can't just fire and forget.
Great, thanks. Yeah, any questions?
I was just wondering, with ChatGPT and the delay it has, as far as the data it's trained on, it's a couple of years, like it's not current. So how hard is it for these models to actually be trained on close to real? I mean, that must be a hell of a lot of data to be keeping up to date with. I'm wondering, how important is it for OpenAI to have as close to real time as possible?
Well, AI, like any type of machine learning model or deep learning, it's garbage in, garbage out. So the data that you put into the training is the most important ingredient of the model. And OpenAI has trained the model on terabytes or petabytes of data. So it takes a lot of time. It's very expensive to clean it and to keep it up to date. And what they want to do, it's not fine-tuning with newer data all the time. They want to pre-train the model from scratch. So that's why it takes a bit of time to retrain a model. You can't do that over the weekend. So that's just a matter of cost, I would say, for now.
So I think, Johan, you had in your slides what it would take to retrain a model of the size of GPT. It was about 3.5 or 4. We don't actually know how big 4 is, but I've heard numbers like 1 trillion parameters. Suffice to say, what has come out is that it's cost them about $100 million in compute, not in the hardware, just the compute time. That's a lot of money for retraining, but what I will say is, given the take-up of these tools, arguably they have an incentive to keep this model up to date. I think we will see a GPT-5 or something similar, within the next year is my guess, because the economic benefit from it is I think big enough to justify retraining it again for $100 million, even if you do nothing else. Get up-to-date data and retrain it. My thinking is that perhaps they also want to do a few other things whilst they're at it. There may be some issues with the use of copyrighted material, which if they can resolve that, that would be nice. There may be some new architectures that they want to try out. But I think, GPT-4 is not the last GPT, that is for sure. And given how useful it is in so many places, they will want to create a model that is a little bit more up to date, and maybe even commit to say, we'll update this on a biannual basis, or perhaps even an annual basis. Certainly, the value it can create is worth 100 million a year every year from now on forward. That much is clear.
Great, thanks. Any other question or comment? Okay, so yeah, just let me finish. You were mentioning about these things in the future. So what are your thoughts about the future coming? Usually we're saying, oh, in the next 5-10 years, but now maybe it's in the next 6 months, 9 months, because things are going so fast and things are changing. So what are your thoughts? What is coming? What are going to be the new things in the next 6 months, 1 year time in generative AI?
That's hard to say. I mean, the field is moving so fast. You keep being surprised every day. Really, your guess is as good as mine, I would say.
Yeah. So this is something that I have noticed historically is we talk about AI winters, and I've never had an AI winter, so I wouldn't know. But back then, that the field got like $10 or $20 million a year, which can just about keep it alive, right? There's a few key figures who can keep going, but we're not in that world. We're in a world where billions, and I think close to hundreds of billions of dollars are thrown at this problem every year. And what we have seen historically is once a field is on the receiving end of that kind of money, the fundamental breakthroughs and cumulative improvements, both of them follow. So you're going to get your somewhere between 5 and 25% improvement year on year, just every year. And then every few years, you're going to get that 200% kind of breakthrough. And over the course of a decade, that will move the field. So I think for better or worse, these tools are going to become more powerful. And we need to be ready for a world like that. We are talking about AIs that are human level. In many ways, even GPT-4 is superhuman in terms of some of the things that it can do. But I think we'll get to a point where it might even get to the point where it can start doing real science. And again, depending on how you look at these things, it's either very exciting or very scary.
Great, thank you very much. So yeah, I think it's time to conclude this webinar. So yeah, we had these 2 amazing talks by Johan and Paul. So I'd like to finish thanking you very much for these very insightful talks. And I think it was very, very interesting to understand how this technology works, all the tools, how to use and develop like generative AI right now, and what are also the business and political implications of using these tools. So again, Johan, Paul, thank you very much. And with that, we conclude the webinar today. Thank you very much.
Thank you.
Bye.
Thank you. Have a good day. Bye.